So we're going to talk about the quotient rule. So in this video, we've got f and g defined to be differentiable functions on an open interval where g of x is not equal 0 in the interval because we don't want to be dividing by 0 here. And f divided by g is derivative defined to be g of x times the derivative of f of x minus f of x times the derivative of g of x, and then divided by g of x squared. The reason I teach the product rule the way that I do, it's very similar to this. Instead of a plus, though, it's a minus. It's the first times the derivative of second, and then the second times the derivative of first. So it's that same kind of flavor. There's a reason, pretty much a reason for everything that I do in calculus. So it's all trying to build to hopefully give you a better chance of setting you up to be successful. So here is another goofy saying. And I know it's goofy, but you'll remember it. This is something that I learned, 10, 15 years ago, whatever. And I still remember to this day the quotient rule. The derivative of high divided by low. So high is the numerator, low is the denominator. It's low d high minus high d low, all divided by low low, okay? So you read low d high minus high d low all over low low. Okay, so that's fine. You can do low low is the denominator squared, right? So it's low d high minus high d low all over low squared or whatever, So let's try it out with a problem. Okay, it's so goofy that it'll make you remember it, okay? So low d high minus high d low all over low low. Okay, so what's my low, what's my high? My high is x squared plus 1. My low is sine of x. So how do I do this? I want to compute the derivative using the quotient rule. Well, it's low d high, so sine x, times the derivative of x squared plus 1. It's very important that you put your parentheses here. That's where most people would miss this problem by not putting their parentheses. Low d high, the d stands for taking the derivative, minus high, x squared plus 1, got to put it in parentheses or you're going to miss it, times d low, the derivative of sine of x, which is in the denominator, the low, all over low low. So low low is sine times sine, sine squared. So now I need to simplify. So I have sine x times the derivative of x squared plus 1. Derivative of x squared is 2x. Derivative of 1 is just 0. So that's sine x times 2x. Okay, minus x squared plus 1 times what's the derivative of sine x? That's cosine x. Okay, all over sine squared. Okay, now I'm going to simplify. 2x times sine x is 2 sine x. Now I have a negative here, so that negative is going to distribute with those positives and make everything negative. X squared and cosine x is cosine, or x squared cosine x, so that's negative. And then I have minus again. Cosine x times 1 is just cosine x, and it's negative. Okay, all over sine squared. All right. And so that's my final answer there. I cannot combine anything in here. They don't all have x's, and they don't all have cosines, so that's it. That's the most I can simplify it, this divided by this. So the quotient rule, the derivative of this nasty thing is something even nastier. All right, let's try another example with the quotient rule. So we have the derivative of tangent. The derivative of tangent here. Well, we know from a previous video that we're supposed to memorize that the derivative of tangent is secant squared. But why is it true that the derivative of tangent is secant squared? That's the question, okay? So it's true. How? Well, through the quotient rule. Tangent is sine divided by cosine. So I'm going to use the quotient rule on sine divided by cosine. So low d high. So low is cosine x times the derivative of sine. Derivative of sine is cosine minus high sine x. D low, derivative of cosine is negative sine, all over the square of what's below. So low is cosine times cosine, which is cosine squared. Now, what do I know? This is cosine times cosine, which is cosine squared. Negative sine times negative sine is positive sine squared. What is sine squared plus cosine squared? That's equal to 1. So this numerator simplifies to be 1 over cosine squared. Now 1 over cosine squared, reciprocal here, is secant squared. Therefore, the derivative of sine over cosine, which is tangent, is equal to secant. Okay? So some very powerful stuff we got going on there. The derivative of tangent is secant squared.